It's a pleasure to be here and to be talking about monitoring the cloud. I like this opening statement. There are currently no cloud providers that can give a true indication of the performance of your application. It's a little extreme. It comes from a vendor that offers some performance monitoring capabilities. Nevertheless, the key word there is give a true indication of performance. You will get some indications of performance on a cloud application as it runs. Amazon in particular makes an effort to make some metrics available. But the fact is by the time you have your application running in the cloud, it'll be much more difficult to see what its performance truly is, as Mr. Hammer indicates. And then an acquaintance of mine, someone whose opinion I respect, David Linthicum at CTO of Blue Mountain Labs, has made a similar statement. He just spoke at Cloud Connect, a show in Santa Clara last week. David says, in cloud computing, there are good surprises and bad surprises. Performance surprises are almost never good. And that is a voice of experience. Slide 8. So if you think you're running slow, how do you know that? What do you wish you could see when your suspicions are aroused? In fact, a cloud application, an application running in the cloud is a much more complex system than an application running on a single server in your data center. You have much more isolation and visibility into that single application on premises. By the time you get to the cloud, you are dealing with a data center at a remote location that's acting as an extension of your data center. There are one or several network segments in between you and that application. Any indication of performance that comes to you is going to have to come down over those network segments, usually the internet. The cloud data center may have slightly different hardware than the one you're used to running your application on. You will not know exactly what hardware it's running on because you'll be in a virtual machine, and you will be running that application perhaps in a different virtual machine configuration than the one that you have been used to, or it may be simply the application has been virtualized for the first time as it runs in the cloud. All of these factors make for issues that you might wish you could get second-by-second monitoring on, and it will be difficult to do that. So as you watch your application run, you suspect it's running slow. Is it the application? Is it the cloud? Or is it the network? These are three issues that are difficult to segment and isolate and then get a lot of insight into each one. There's a few things you can do, and they're actually free services today, and many more coming down the pike. But right now, it is difficult to get that true vision, that true view of what your application is doing in the cloud. Slide 9. For example, if you have sent it to the cloud, how long will it take for the cloud to accept and load your application? If you are calling it up out of cloud storage, such as Amazon's S3, how long does it take to be retrieved from storage and loaded into your virtual server and start running? These are kind of ill-defined issues in terms of cloud service. I am not aware of a SLA from Amazon that addresses them or guarantees certain speeds. My impression is you are left to the mercy of the effectiveness of the cloud operation and the circumstance of how busy the elements of the cloud, such as S3 storage, are at the moment that you address it. Another issue would be you need database service in the cloud. You have it, but how fast is it? How busy is it? How big are the pipes between the database and your application. In other words, how fast can it respond to your application's calls for data? Another hidden issue, we assume this works well and people wouldn't be using Amazon to the great extent that they are and other clouds if there were not good database service available. Nevertheless, getting a true view of how effectively the database is responding to your application is a kind of a sleeping issue in the cloud. And then many cloud applications will make use of other services. They will go out and tap a credit check service, an address check service, various services that are available online. Nevertheless, the application needs to go out to another site, tap the service, get a response, and have that response returned to it. How effectively can your cloud do this? Again, I haven't seen metrics applied. I haven't seen careful measurements that this cloud excels at that. Another cloud does not. Another kind of sleeping issue that we wish we knew a little more about. Slide 10. Now, let's take a look at Amazon just for purposes of example. Amazon is the leading cloud supplier. Its cloud business is believed to be approaching $1 billion in revenue a year. It may even have crossed that mark at this point. Nevertheless, despite its very strong position, Amazon suffered an outage at its most popular, most frequently used data center. I don't literally call it an outage myself. It happened over the Easter weekend in April 2011. It was more of a slowdown and then freeze up of some services. The services involved were Elastic Block Store, which would have the data that your application is using as it's running. It's a kind of temporary storage inside Amazon, makes the applications run very effectively, but nevertheless, a backup network was inadvertently selected and plugged in as a main network to Amazon's Northern Virginia data center. It was a human error, but doing that resulted in many applications not able to see their data any longer. The thing that caused the slowdown and freeze up of some services was the cloud's own mechanism that it wants to know a copy of the data is available at all times. In effect, a basic cloud operating characteristic is to have 3 copies of data at all times. If one disappears, there are still 2, one for use, one for backup, and one of them is designated a new primary copy and a third replication. Then the system sets about making a 3rd copy once again to make sure there will always be a copy of the user's data. With that network mix-up, data disappeared for many systems, and they started seeking their backup copies, kicking off a need to replicate yet another copy so that there would again be 3 copies available. Amazon called the resulting overactivity a remirroring storm. Too many systems were trying to create fresh copies of probably, in many cases, large data sets. And it began to tie up Amazon's operation in part